Oh, hey, sixth graders, I didn't even see you there. I was just into my book I was reading here. Well, hope y'all are doing great today. I'm rocking a sweet new do and a sweet new shirt, quarantine and teach. That's my life right now. So I'm pretty excited about it. Okay, we're going to go on to lesson 43, working with creating equations based on word sentences or story problems. So let's get to it. We're going to go ahead and do 3 problems together before you work on your own. So before we do that, let's read the multiplication rule and the addition and subtraction rule. So the multiplication rule is the total is equal to the rate times the stage. The addition and subtraction rule is the total is equal to blank, so some number, plus or minus the stage. So with equations, something that can happen is things can be rearranged. So let's say if we're working with multiplication and we wanted to find a different part of that equation, we could use division to solve it. Same thing with addition and subtraction. If we're trying to find, if we kind of have an addition, one equation that has addition, we could use subtraction to solve for the missing part. So you have to read really carefully with these problems because what you might think they're asking you to do, it could actually be the opposite. You might think it's an addition problem when really what you need to do is subtract to solve for the missing variable. So you got to read carefully, and I'll help you through these first 3, and then just make sure you use those close reading skills to make sure you know what you're supposed to do. So let's look at number 1. George was walking down a field that was 300 yards long. He has already walked X yards down the field. Write an equation that represents the number of yards, Y, George has left to walk. Okay, so first when I saw this, I thought, 300 plus X would tell us how far he has to walk. But 300 is the total. So he's got this distance here, and that's the total. He's only walked this far. He needs to get to here. So we got to think about that and think about what operation best fits to solve the problem. So I'm going to actually draw a model of it, and this might be something that helps you if you get stuck and are not sure which operation to use. So let's draw this out. Oops, I got to pick up the marker here. Okay, so we are looking at this distance. I'm just going to draw that out. So the total right across the bottom is 300. So it's 300 yards. Just for the sake of time, I'm not going to write the units, but 300 yards. Okay, George has traveled a certain amount. We don't know. He could have gone this far. He could have gone this far. He could have gone almost all the way. We're just going to put him kind of in the middle here somewhere. So he's traveled X. So he's gone this far. We are trying to solve for, it says write an equation that represents the number of yards Y George has left to walk. So we're trying to solve for Y. This is the part that's a mystery. Okay, so we don't know how much more he has to walk. Technically, we don't know how far he has walked either, but if we were given that X value, we could solve for how much more he has to go. So when we're looking at the multiplication rule, it says the total is equal, not the right one. The total is equal to blank plus or minus the stage. So we have the total. So we've got to figure out, do I add on X or am I going to subtract it to solve for Y? Since it's the total, I can't add on X because that would make my total larger. So I know I'm going to have to be working with subtraction. And I'm solving for Y. So Y is going to be on one side of my equation. Y equals, and then we have our total, 300 yards. So like I said, this one's one of those problems where it's kind of going backwards from what you might have thought when you first read it. So Y equals 300, and we have to subtract X to solve for Y because we're trying to figure out what we're missing to get to the total. So 300 minus X. So if we were to say, in this X, he traveled 100 yards, I could take that and say, I can solve for Y. I can figure out how much more he has to go. 300 minus 100 would tell us that Y portion, the number of yards left, is 200. So we could solve it by saying George has 200 yards to go. But we're not given any numbers to solve it. That's just an example. All right, that's number 1. So I'll leave that there for a second. Actually, I'll just make my little thing smaller and read the next problem. So number 2, Jersey's T-shirt company charges S dollars for each T-shirt they sell. So we don't know how much those shirts cost. Martin's basketball team bought 30 shirts. Write an equation that represents the total cost of the shirts. Okay, so I'm going to go ahead and erase this so I can scroll up. Okay, so this one is more of a straightforward problem, more like ones you've worked with before. So they charge S dollars for each T-shirt. So let's say this T-shirt costs $10. Then we could take that and charge or multiply it with however many shirts we buy. So similar to one of the problems from yesterday's lesson, we're working with a unit rate of some sort. The shirts don't all cost different prices, so we can use multiplication because they're all the same. So we'll say a T-shirt. Okay, come on. I want you to draw. So the T-shirt is S dollars. So we don't know how much each one costs, but we know how many we bought. And that is, they bought 30 shirts. So we've got S number of dollars times 30. So very similar to other problems you've done. We can write that as an equation, and we're going to write it in terms of the total cost. So we're going to say, so whenever you look at this bottom part here, this bottom sentence, that's telling you what should be on the one side of your equation by itself. So C equals. So when you look at the next one, F is going to be on one side of your equation. That, because it's telling you to write it in terms of the total cost. So it's telling you what should be on one side of your equation. So cost equals, and we already kind of solved it here in this little drawing. So S times 30, or we can write it as 30S, because we don't necessarily need a multiplication symbol in between the two, because we know when a number is next to a letter, it means to multiply them. But if you like to have that dot, you could use that. I would not encourage you to use this type of multiplication symbol, because that can be easily confused with the X variable now that we're working on algebra and such. So either use a dot or just leave it like this. So if we were saying that the shirts each cost $5, we could say cost equals 30 times 5. We would know that the cost that the team paid for, the basketball team paid, would be 30 times 5, which would be $150 for their t-shirts. There's if we were to try it out. Okay, let's read number 3. Alex was doing a free throw shooting fundraiser at school. Her grandmother gave her $3 for every free throw she made. Alex made a total of T dollars. Write an equation that represents the number of free throws Alex made. So this problem is kind of mixed up. We're not solving for the total, so we might be doing a different order of the equation than what we might have thought at first, like we did in the first problem. So let's erase this and move it up a little bit. Okay. So Alex is doing free throws. She gets $3 per free throw. Okay. And she made a total of T dollars. So we don't know how much money she made, and we don't know how many free throws she made. All we know is she makes $3 per free throw. So we're going to write down. So we're trying to solve for the number that she made. So we have F on one side here. So free throws. How many free throws did she make? So how am I going to figure that out from the total amount of money she made? So let's say she made $30. We don't know for this for sure. We're just using it to help us solve. So let's say she made $30. From there, how am I going to figure out how many free throws she made? So she made $30 and she gets $3 for every free throw. Would I multiply the numbers? Well, that would put me up to 90 free throws, which doesn't make sense because I know that she makes $3 per free throw. And if she made 90 free throws, she would be making a lot more money than $30. So I think I'm going to have to do the opposite of multiplication and divide. So if I take $30 and divide it by $3, then I would end up with 10 free throws. That sounds a little more reasonable. If I put that in as she makes 10 free throws, and I say 30 divided by 3, yeah, it equals 10. It works. So we're going to say that T, the total amount of money she makes, is divided by 3. That will tell us the number of free throws. So this problem was a little tricky because you weren't solving for the total. If we were solving for the total number of dollars, the equation would be written like this. Total number of dollars, because that equals total is T dollars. We know the money she makes is free throws, 3 times F. So that equation was easier to create because it's more straightforward. I know, if she makes 10 free throws times $3, that means she's going to get $30. We had to work this backwards. And what we did is we wanted F to be on the one side of the equation. So in order to do that, I had to divide both sides by 3. So then I ended up with T divided by 3 to get F by itself. So that's a little bit, we haven't done a whole lot with that. But that's why I was saying you have to read these problems really carefully because sometimes they're not doing the operation you think. So if it helps you to draw a picture, that's a great way to do it. If it helps you to create a fake story problem to figure it out or a fake number to put into your equation like I did here, then do that because that was how my brain had to think through it. So I had to think, if she made $30 and I know she made $3 per free throw, that would tell me how many free throws she made. So $30 divided by $3 would tell me she made 10 free throws. All right, that is it for our examples for lesson 43. So good luck with the rest, 6th graders. You got it. Miss Waage out.